Nope, never mind. It's not going to do it. I tried. All right, welcome back, everybody. Here's what I left you with. And I said, hey, don't care what you come up with. I want you to spend 5 minutes trying this. We're obviously going to do this now. Anybody feel like you got it? Okay, so I'm fine with that. Before we jump in and I just say, oh, here's how we do it. This direction is noticeably harder than just adding it, right? Like switching this up makes it a bit harder. Did everybody, before we just continue on, when we did the number 1 here on this example, rational numbers, did this part seem reasonable for everybody? Like everyone was okay with how we got this? If you're not okay with it, now's not the time to be silent. Thumbs up, thumbs down, just so I can get a good feel for it. So if I said find two numbers that get to 5/12ths, the easiest answer is 1/12 plus 4/12ths, or any 12th plus another 12th that adds up to 5. Alternatively, if I said, hey, make them different, all I have to do is just change this. 1/12 is, I did it here instead. 1/12 plus 1/3 gets me there. Or I change 3 plus 2 over 12 to get 5, and I just change these to here. So I know that this is a way to add up to 5/12, and so is 1/12 plus 1/3, and there's more of them. Okay, this problem is doable, I think. And I think both of these are doable, but as long as this one truly makes sense, we're going to see like the exact same thing happening here with a little bit of added stuff. So I don't intend to give you any direct guidance. I just want to see what we as a class or units can come up with. If you've not thought about this yet, has anybody not thought about this at all since yesterday? Appreciate the honesty. For real, all of you guys did? Okay. So this morning, that's okay if it's 5 minutes at some point. What would you like me to try? There is no wrong answer here. Factor the denominator? Okay. Gosh, you know what though? It's Friday and it's a rough Friday. I forgot how to do this. Well, that's okay because JV is going to hook it up. When we factor, what do we do? Okay, I don't think there's a greatest common factor between 1 and 6 and 8, but I love it. Ken, after we check for GCF, what's the next thing we check? So, good, I'm okay with that. You said multiply what times what? So is it the x squared that I'm actually multiplying, or is it the number in front of it? Okay, so that's a 1, right? Now, I want to highlight here, this is perfect next step, just so you know. You skipped the binomial part because you probably recognize that it's not a binomial. Okay, as long as that check was in your head, I'm good with it. All right, now I need factors that do something special, I think. Barcega. Cool. Did you stop by the office, or is that from Miss Allie? Okay, I can fix it on my end. Okay, what do I need to do with this 8? What's the point of it? Sorry, I asked you, right? Okay. Okay, so I need two numbers that multiply to be 8, but add up to 6. If I reword that factors of 8, that's sum to 6, right? Just to make sure that we're hitting this factoring idea. Okay, what are they? Two numbers that multiply to be 8, but add to 6. 2 and 4. What if I want to write 4 and 2? It doesn't matter, not at all. Okay, it's at this point that you finally have to check to see if we can apply the shortcut. Because if you are comfortable getting to this and then you still get your factoring stuff wrong, it's going to happen here. Is there a shortcut available? How do you know, Angel? Love it. The fact that my leading coefficient is a positive 1 means there's a shortcut. Means that this guy factors as x plus 2 and x plus 4. All right. So your first suggestion to factor, that's awesome. Kalisha, just so you know, I am giving no guidance on this problem. I'm just asking people from the thing that I left with yesterday, like, what should we try? Cool. So somebody suggested, and I don't remember who even, but somebody said, hey, factor the denominator. Okay, I'm good with that. Now what? Fern, I saw your head turn like there was a big thought moving your brain around a little bit.
Do we not need to factor that? Because can't we just make the denominators of A and B the not factor themselves? Just add the denominators to make it x plus 8.
So your thoughts there? What Fern is suggesting is that maybe he didn't want to factor. And again, there's no guidance here, so we're just playing around with it, right? If we hadn't factored, we would just be left with this. And then you said do what?
Just make it so the numerators add up to x plus 8.
So I need two numerators that add up to x plus 8. And what would the denominators be then?
X squared plus 6x plus 8.
Okay. I'm okay with that. Can you be specific? And this might be challenging. This isn't necessarily the same thing. Here's like our first option that we tried, right? I'm just going to box these because if they're not related, I don't want to make them look like they're related. Okay, what would you have me write instead? This is one approach.
X over x squared plus 8 over x squared plus 6x plus 8.
Plus 8 over x squared plus 6x plus 8. And that would work, right? Now, as we're looking at it, with that in mind, are there other possibilities that would have worked? Like, you've just done essentially the same thing we did here, right? And I'm totally cool with that. I like it. I like this idea because you're relating it exactly to what we did. This is no different than when we did the 1/12 plus 4/12 part on the other one. We've just picked two arbitrary things. Now, in the end, maybe, just maybe, we want to be a little bit more specific so that we don't have infinitely many answers to choose from. Because literally infinitely many things add up to x, and infinitely many things add up to a positive 8. And we need a way to kind of zone in or narrow that down a bit. Infinitely many is too many for us to deal with. Okay, there's going to be a mix somewhere between here. I love both of these options. And we're actually going to kind of combine these to make sure that we don't get all infinitely many possibilities and we just zone in on, hey, there's one really good possibility or one really good way to write this. Okay, this is our intuition for the section. Now, we're going to jump in. I called this partial fractions because notice we have a fraction and we're finding parts of that fraction. That's all that we're doing. What's cooler than just that, which I think that's pretty cool, maybe you guys don't, the value in this, just so you guys are aware, a big fraction is harder to deal with than a little fraction. Do you agree with that statement? Sorry, yeah. Big fractions are ugly, little fractions are easy. So if we have a way to write things as easier, littler fractions, maybe if we have some big ugly expression that's rational and that's really ugly in the numerator and denominator, we could break it into these smaller pieces and deal with each of those instead of the one large piece. Seems reasonable. Okay. So what we're actually looking at is like the most fancy sounding math topic that we've covered in here. Our main section, and all of that we did just now, all of that was just intuition for what we're looking at today. We are going to start looking today at what is known as partial fraction decompositions. Okay. I don't like to write all these words over and over. So outside of Alaska, this doesn't resonate anywhere else, but PFD. We are doing PFDs. Hopefully you've gotten your PFD for this year already. Cool. As we're looking at this, our end goal is just answering this one singular question. I don't want to just necessarily call it the best way, but can we all agree that we're going to do something that ensures that we all decompose these things into their parts in the exact same way. So a uniform approach to solving these problems so that how you break it up is the same as how you break it up. And if we were to compare this data, we'd all have the same stuff in front of us, even though we could calculate these out elsewhere. Okay, so the big question that we're looking at is how to write a rational expression, which we're going to deal with fancy ones. If I'm going to have some polynomial with a variable x, or a polynomial in terms of x, what do we call the numerator? Because we've done it before. Something over something. What do we use with rational functions? This is a numerator in terms of x. How did we write that before? Good. It's n of x over d of x. How do we rewrite this in parts? Is really all that we're asking. And I didn't write it here, but remember, it's how do we all do it the same way to ensure that we get the same parts of this. Okay, so looking at these, we're going to get pretty algebra heavy, so if you need to stretch, do so. I'm going to give us, do you want to work an example? I'm going to give us the rules, and then we'll look at it and apply them in different situations. This one's not going to be as nice to just annotate through. So I'm going to call this guidelines for how do we actually do this. And what's super cool about having you guys think about it a little bit is everything that we've written so far on the board shows up today. So kudos to you guys. That's great mathematical kind of intuition and guessing. First off, if it just so happens that n of x over d of x, which is just our ugly big fraction that we start with, if this thing is improper. And before I continue, that doesn't mean anything unless we all really understand what it is. With your neighbors, I want you to talk and discuss what does it mean for a fraction to be improper? And when you think about just regular numbers, how would that extend to these polynomials? What makes a fraction with x's and expressions here be improper? I'm going to give you a second. Dig back through your old math language. Right off the bat, I heard two things that were the same idea, just worded differently. Sean said that an improper fraction is just the numerator is bigger than the denominator. And then Ferns took a step further and said, well, how do we talk about the size or how big this is in this? Because it gets weird with x's, right? If I ask which function's bigger here, and you don't have to write these. Let's say I have this one, 2x squared plus 5, and this one is 2x squared minus 5. Is either of them really bigger than the other? Some of you probably say yes, and some of you say no. Anybody in here say yes? Interesting. If somebody says yes and they're being shy, this is the part that makes me want to say yes. Something plus 5 is definitely bigger than something minus 5, right? Now, in that case, that seems fine and dandy, but it's really easy to show that that just doesn't work. If I have something like this, 2x squared plus 3 and 5x squared minus 20, now can you tell me for sure which one's bigger? I don't think so, because sometimes one's going to be bigger and sometimes they're going to switch, right? Because they're going to intersect. So we need a way to talk about this. Gosh. I'm going to change it up just a skosh. I'm going to write a fraction. I want you guys to tell me just based on gut instinct, is it improper or proper? So here we go. 3x cubed plus 7x minus 1 over 2x squared plus 5. No real thought to it, just gut feeling. Kalisha, is that fraction that I just wrote proper or improper? Improper. How about you, Abigail? Fern? Why? Oh. Is it the powers? What do you mean? Oh, look at that. There's a better word for it. But yeah, it's exactly the powers, but I'm not going to call them the powers. The largest exponent or the largest power that shows up in an expression has a special name. The degree. So check it out. All this means, if it's improper, we would just say, oh, that requires, or that says that the degree of n is greater than the degree of d. This is an improper rational expression. If this is a case, we divide. You just apologize for coughing?
Because Nikisha moved and I was like,
Oh, okay.
sorry.
I didn't see who you were talking to. I was going to say, you don't have to apologize to me for coughing unless you didn't cover your mouth. Okay, cool. Okay, to get, and I'm just going to leave this blank for 1 second, we're not going to review all the division stuff. Not right now. If you need to, I can help you with it. But if we divide this, how does it work? What do we get when we divide stuff? And it's pure language stuff, but we're going to make sure we hit it hard enough. What do you call the answer to a division? The quotient. And how do we write this when we looked at stuff earlier this year? Q of x, I think, is what we used, right? Okay, so if it's perfect, then we're done. But if it's not perfect, we wind up with, this is new notation for a second, something like this. Now, I've called this n sub 1. That's not what we called it when we did this stuff earlier, but there's a reason to it. The stuff that's left over is called the what? The remainder. And here we go. I'm just going to make sure that this is really clear. This is our remainder if this happens. Okay. If we have to change it here, we will now use n1 of x, whatever that remainder happened to be, and continue. So everything that we've done just now is just in the case that we have an improper fraction. The good news is that, at least to begin with, every fraction that I'll give you initially will be proper, so you don't have to deal with this, which means you'll just start right at step 2. Cool. Baller. Kicking forward then. Once you've decided or fixed it if it was, or recognize that it's not an improper fraction, we are going to steal, I don't know who suggested our first step on this problem. First box, I just don't know who it was. Okay, Abigail, and I think Sean, you mentioned factor it right away yesterday in class when I presented this. So yeah, I'll tell you, we are going to. We are going to factor the denominator, which based on the way that we write these, instead of saying factor the denominator, I'm just going to say factor d of x. Into, and this is where it can get a little bit wonky. It's not going to get crazy here. We're going to get into prime factors. Okay. If you give me an expression, I say factor it. Anything that's a cubic, a quartic, doesn't matter how big it is, there's different types of factors, right? I get linear factors, which are super duper nice. Those are x minus 2 or 5x plus 3. And we'll write all this down here in a second. But sometimes I get quadratic factors. If I get something like x squared plus 1, I can't factor that any further unless I go into the complex numbers. Like, I'm just not going to do that. So we're just looking at our nice normal ones. We're going to say prime factors. And just so that we can see what they look like, these are going to have the form of, lost my train of thought, sorry. Px plus q is what I'm going to use. And maybe this shows up, I don't know how many times. We'll just say M as in Mike, where quick review of stuff, because we're just using letters to represent numbers, right? This is no different than 5x plus 1. Just P and Q are numbers. What does M represent? And there's a few ways you could explain this. It's an exponent for sure. There's a fancier word that we use that starts with an M as well. It's my multiplicities, how many times it shows up. Okay, we're going to get, for our stuff, factors like this that are completely prime, or maybe they're going to be more hardcore, and they'll have the form ax squared plus bx plus c, and be quadratic factors that can't go any further. So I can't factor by grouping. I can't find any rational roots or factors. And maybe that one shows up n as in November times. Okay. Once we have our factorization of this, we're going to have some number of factors. 2 or 3 or 4 or 10. Doesn't matter how many we have. We're going to have our list of factors written out. Okay. Once we're here, this is where our work clothes are really needed. For each linear factor, which I didn't write it above, but of the factors that we've written in step 2, which one is linear? Px plus q or ax squared plus bx plus c? On this line right here, which of those factors is our linear factor? The left one, px plus q, because it's just x to the first power. Okay, for each linear factor, the decomposition or the partial fraction decomposition, PFD, must include the sum of factors. Very specifically, what this means in this situation is that if we have these, let's say this number showed up m times. The way that we're going to sort this out is we're going to take, there's better language, we'll work this out, but check it out. We have a1 over my first linear factor plus, and then this is where we'll have to really refine this language. I have some factors, cool. Is it possible that this one showed up 5 times, like px plus q to the 5th power? Or even to the 2nd, or m, whatever it is. When and if this happens, all that we're going to do is we're going to start building up this factor, and each step along the way, we'll just keep going until I get to the number of all of them. So the first one is a1 over px plus q, and then we get a2 over px plus q to the second. And I'm going to keep going. What this one is going to be to the what power? You skipped one, I think. 3, right? Plus, I'm going to say dot, dot, dot. How many times in this general form did this factor show up? In step 2, it showed up how many? More than 2. M. Good. I'm just going to say dot, dot, dot because I don't know how big it is. A sub m over px plus q to the m. Okay, so we're going to have a list of m of them. All right. If it's quadratic, step 4. If for each quadratic, and I'm going to make this even shorter. Similar process for quadratic factors. And as ugly as this looks, I'm very much so right now reconsidering if we should have just done an example simultaneously. But we'll get through it together. Look at us, we're all learning. Cool. In this one, I don't want to confuse it, but here we go. B sub 1x plus C1 over, and this is going to be, I'm only going to write 3 of these. The first one, let's say it showed up n times like we did with the previous. We're going to have our ax squared plus bx plus c to the first power. Just like this one was to the first power, but we don't draw the 1. Plus b2x plus c2 over that same factor. But this time, it's the second time that I'm using it. What power should I have? 2. Plus however many more I need to skip until I get to the nth and final factor of this form. B sub n x plus c sub n over this mess, ax squared plus bx plus c to the nth power. Cool. There's a lot of writing, but we're going to be able to use this, and this is going to cover every possibility that we'll ever encounter with it. All right. On a scale of 9 to 10, how easy does this seem? And you like, that's such a weird scale, but it makes it sound awesome. You gave me an 8, which I don't know how to make sense of that. I also, just to be clear, I never said which side was, yeah, exactly. Yep, so this is where it gets weird. This seems like a lot, I imagine. Anybody else look at this and go, oh my gosh, I hate this so much already? Check it out. Everything that we're doing here, this is as generalized as a mathematics can get. General math always looks so much scarier. Just like if I gave you x squared plus 5, that's not scary. A sub n x to the n plus a sub n minus 1x to, like, that looks scary, but it's not. Same thing is going on here. Let's do a decomposition. So, do we need to do a quick brain break right now? Okay, with your neighbors, I want you to tell me one thing about you that's not like crazy personal, like make it school appropriate. Something about you that even the people next to you who you're best friends with, I assume, because you're all sitting next to each other, doesn't know about you. Cool. I'm going to ask 5 random people for something like what I don't know about you is going to be super easy because I don't know a ton about all of you. But cool. Talk it out. We get 2 minutes. I want first minute for you guys, and I'll ask some people. Let's keep rolling. This looks awful. It's not awful. This is generalized mathematics. It looks awful so that we can make sense of like every possibility. Let's do some partial fraction decompositions. Sweet. Cool. So, you guys have the list of stuff on your page, I hope. Cool. I'm going to work an example up here. Let's decompose, my guys. Find a PFD. Now, algebra muscles. Warm them up, stretch them. We don't want to tear anything. Looking at it, here we go. I want us, I'm going to leave this blank for a second because I'll give us a heads up name of this. Here we go. I want us to decompose the following. X plus 8 is my numerator, and I'm going to divide this by x squared plus 6x plus 8. All right. Now, in this class, it's a little bit easier because we don't do a lot of plugging in numbers right away. We just work with the variables until, we usually just keep them that way. Here's my first piece of advice. I'm going to do these like the exact same every single time. I would strongly recommend we'll write equals here, and then we're going to have some room for scratch work. Whether it's below or to the side doesn't matter to me. This problem isn't going to be terribly long, so I'm going to do all my scratch work down here. You don't even have to indicate that it's scratch work, but I'm going to. Okay, right off the bat, what is the degree of our numerator? It's a 1. So the variable is x. Remember, the degree is the largest exponent connected to it. It's a 1. How about the denominator? It's already proper. Step 1, we're done with. We don't even need to look at it. We don't need to do any division. It's completed. Step 2, what do we need to do? I need to factor. What? Okay, so at your desks, I want you to factor for me. Do I have the right thing? We're going to fix this so it works. Sorry, anybody writing in pen? Good. We're going to make this a 6x because I mixed up problems. X squared plus 6x plus 8. Sorry about that. And I'll change it to red so it stands out just so you can see that that's what I changed. My bad. Okay, I'm going to give you like 40 seconds. Factor that for me. I'm not going to show any work because I can think of factors of 8 that add up to 6. What are they? 4 and 2. What's the leading coefficient of this trinomial? Oh my, shortcut. X, I hate that. Hate that I did that too, but that's all right. X plus 2, X plus 4. Okay, we have it. What is the multiplicity? And I'm going to ask the same question like 4 different ways. What's the multiplicity of that first factor, X plus 2? 1. Same question, worded differently. How many times does a factor x plus 2 show up? Once. Which means when I write out my list, it only has to show up once because I don't have to work up the first time, the second, the third. I don't have to work up to it. This name, we'll put it at the end, but I'll just tell you, this example is called distinct linear factors. And I'll add it at the end as well. But check it out. We have 2 factors that never repeat. That's it. Which means my parts that I'm going to use to sum up to this, there's only 2 of them. 1 for each factor, because there's no repetition. So when we jump into this next part, here we go. We have some number a over that first factor, x plus 2 times x plus 4, plus some number or expression b. I am wrong here, just a little bit. No change, just an erase. Each factor gets its piece. A over x plus 2 plus b over x plus 4. Sorry, I was excited to do the rest of the math that's coming. All right. Now, this time, I'm going to make this bigger than it really will be when you do it, but I want to make sure that we have room to think about every little piece. We've done the first part of it. What do you think we're going to try to find? So we know what the common denominator is already. It's going to be x squared plus 6x plus 8, right? Now, when we look at this, we need to find a and b. Like, that's our goal. You do not have to write this unless it is needed. We need, first of all, to be able to write it. We want, rather, we do need to, but we want to find a and b. Okay. To do this, it sucks to deal with fractions. But we can bust the fractions. I'm going to say ... bust dem fractions. Bust dem fractions. You can butt them if you want to, but I don't know what that would do. Okay. Fraction busting is your guys' language that you learned with Jarvis, right? What do I mean bust the fraction? I'm going to use, I think so. I didn't quite hear what you said. If I say get rid of denominator, is that same thing? Okay. So here's the deal. I'm going to rewrite this expression, and it's a pain in the butt, or bust, maybe. I'm going to rewrite this, and I'm going to leave awkward spaces for a very particular reason. Normally when I do this, it all happens on this first line, but let's just dig in. I'm going to rewrite this one. X plus 8 over x squared plus 6x plus 8 equals a over x plus 2 plus b over x plus 4. Nothing different has happened. If I wanted to make a single common denominator on the right side, I already know what it's going to be. It's going to be the x squared plus 6x plus 8. How do I undo, quote unquote, then? Divide by that. I'm going to do exactly that, and this is the first part that's going to be weird. On the right side, sorry, on the left is where I'll start. To bust this fraction, I'm going to multiply everything over here by x squared plus 6x plus 8. The second I've done that to the left side of the equation, I also must do it where? Okay, here's where, don't write it yet. I want to make sure that you guys look and listen and acknowledge what's going on. I can write this another way. If I do this and just multiply it by x squared plus 6x plus 8, just like I did here, and I write it the same way, nothing obvious seems to happen. However, if I multiply it instead by this thing, which has an x plus 2 and an x plus 4, and I didn't need that bigger parenthesis, have I multiplied by the same thing? These guys right here are the same. They just look different, right? One's a factored form, one's not. You don't have to do this, but there's a reason that I do it. On the left side, when we actually carry out that multiplication, they gone. Which means I'm left with x plus 8. Okay. This next part, people get goofed up on the algebra. We're not going to get goofed up on the algebra. When I distribute, both of these terms, a over and b over, get multiplied by this whole thing. Okay. When I do this then, here, can you tell me which part of it divides out? So louder and more specific, I think. So you're right, some of it divides out. So what do I have left when I do this multiplication then? Don't distribute it yet, just give me the a times something. You're absolutely right. Say it confidently, whoever that was. I think it was Angel. X plus 4. Bless you. Can everybody see what just happened? Now, the mistake people make with distribution is inevitably somebody, even without me saying to do it, cross this off when you did it. Did anybody do that in here just now? Fantastic. Never mind then. If you cross it off, you're going to lose it, and you're going to act like it's just gone. It's not. When I distribute this piece through, I'm left with a b times what? X plus 2, because the x plus 4 is just divided out, right? This expression looks simpler than the first one, and just because you can't see me pointing, if this is alpha and this is beta, which one looks easier to deal with? Alpha with the big fractions, really? I mean, it could. Maybe it does to you, not to me. I think the thing without fractions seems ideal. Okay, now, this equation right here has a name. And sorry about just the constant color changing. This is what is known as our basic equation. This, nope, not caps yet. This is our basic equation. Okay. Now, beyond that, this thing is true for every single x that we could ever pick. This is true, and I was going to add it here, true for all x. Gosh, if only there was a shorthand that everybody remembered all the time. Remember, the upside down capital A is the for all. This is true for all x. What this means is I now have a single equation with two unknowns. Now, somebody's probably going, wait a second, there's 3 because we have an x as well. The x is a variable. It can be anything. It can keep changing. And in fact, we'll let it change infinitely many times if we need to. These are my two unknowns, a and b. That's all that I'm after. Now, because this is true for all x values, here's my suggestion. let's pick x values out of our list of infinitely many, since this is always true in our basic equation. Let's pick x values that make a or b fall out. Now, fall out, if that isn't clear, that's language that I use to, we make it somehow disappear, right? If you want something to disappear, like we wanted a to disappear, you'd have to have a times what for that to happen? If I want to say a times something, it's just gone in our equation. We won't even write it again. I'm representing a number there, but we don't ever write it. 0. Is there an x that makes this 0? Good. Makes the binomial in this case 0. That's what we're after. Now, some of these are going to be really obvious. Some of them we're going to struggle a little bit more with because problems will naturally get harder. This is our entry level. So check it out. We've done all this work. Realistically, this is about the only line that I would have written, and then this would be my second line when I'm actually doing these. Okay, we can pick literally any x's that we want. I want you guys to make it a habit to specify so that I can pick out what you're doing, and you can pick out where a mistake might happen. What do you want to solve for first, A or B? There's not a right answer, just so you know. Let's solve for A first, just because it's arbitrary. Okay. I'm going to make it really clear that we're just solving for A in all this work. To make this solvable for A, what would it be really handy if we had fallout? So there's no exponents here, right? But if we had B just go to 0, that'd be really easy to deal with, right? Solving for A is the same thing as let's eliminate the B term. What eliminates B? One more time, sorry. -2? I think that's going to work. Let's check. If I plug in a -2 for every x, and you guys can mental math this if you want to, we get -2 plus 8 on the left equals a times -2 plus 4 plus b times -2 plus 2. I am just plugging in x into our basic equation. Okay, this piece, gone, because it's b times 0. The next part I think we can solve. The left side, what do we get? Equals how many a? 2a. What do we now determine that a is equal to? 3. Look at that. We have one of our two pieces right off the bat. What I want you guys to do for me real quick is I want you to solve for b. Physically write down let x equal. Tell me what you're choosing so that we can get a to fall out and we can solve it for b. If we want a to fall out of this so we can solve it for b, what should we let x equal? So if we let x equal -4, we would get -4 plus 8 is equal to a times, I'm just going to be lazy and call it 0 right now, plus b times -2. Is that right so far? Okay, so 4 is equal to -2b. B must then be -2. Cool. Everybody agree with that? Now, this problem feels so long, but I think we'll be able to do another one in the time left. When we look back at the original stuff that we did, we saw that there were only two pieces to this decomposition because there were only two factors each that showed up one time. I needed a and b from the get-go. Do I have it? Boom, check it out. We now know that it's a over x plus 2, so we get 3 over x plus 2. And I can write plus and negative or just minus. I'll do plus and negative for now over x plus 4. And this is what we need in order to get, let's see, I lost it. X plus 8, right? X plus 8. over x squared plus 6x plus 8. This right here is our partial fraction decomposition. Now, we don't get to see it right now today. I will find applications that we don't need calculus for. But if I gave you the choice of working with this singular expression right here, or these two instead separately, these are easier to work with. By a long shot, these are easier to work with. There's a huge value in making hard problems a lot less hard by doing this. Okay. Question, Shawnee, just now. Okay. All right. I want you guys to do one more for me. Cool. If this doesn't get finished, and this is not like an indication to say go slow, if we don't finish it, this will be your homework over the weekend. If we do finish it, I might give you more homework, but realistically, now that I've said it, that's definitely not going to happen. So, looking at it, I'm going to give you a head start. I want you guys to solve for me. Sorry, and these are distinct linear factors is what this is called. Oh my gosh, way up. Distinct linear. So no repetition. B is also going to be distinct linear, but I'm not going to write it. So here we go. X plus 5 divided by 2x squared minus x minus 1. Now, I'm lazy when it comes to writing. Just so you guys know, the work that I do on the actual problem is so much less than what we get above. I'm going to write equals, and I'm not going to do anything else right here. I'm going to do all my scratch work off to the side. Okay. I want you guys to try this. Eventually, you'll find your two denominators. And then you know that it's probably going to be A and B. I'll just do all the work, and then I'll just put A and B right here next to the original problem that I've written. Cool. Go. Here's my factorization. For this, a lot of the time what we're going to see is we're going to get different values for A and B. Because what you choose for, what you get for A depends on what factor you list first. So in this case, I don't care if you've already done it. I'm going to leave this blank. Here's my A value that I'll plug in later. I know one of the denominators is going to be 2x plus 1. And another denominator is going to be x minus 1. Now, if you want to write A and B and then replace them later, I'm cool with that. I'll erase these later. That's what I've chosen. If you've already written it, do not take the time to rewrite it. You now clear your fractions to get your basic equation and pick x values to find A and B. Don't worry if the order is different than mine. It'll sort itself out because if they're switched, we'll just have A over x minus 1 and we'll get those numbers sorted out. Cool. All right. Pack up. Peace out. Bring me a proposed solution to this, or answer rather, on Monday. Enjoy your weekends. Daily reminder, delete Fortnite, it's a waste of time. Download Rocket League.